Okay, see Lindelof video, Solving Logarithmic Equations 2. So here's the problem that was sent to me, and I was asked to solve this. And it says that log base 10 of x plus log base 10 of x plus 1 is equal to log base 10 of 6. First thing I would say is this to the person that sent me the question. Generally speaking, you don't see log base 10. It doesn't mean that it doesn't exist. It's just it's not usually written this way. So if you have log base 10, the way it's usually written is you take out the bases, and you assume, and if you take them out, if you don't see a base on a log, you assume that it's a 10, and you just call it log of x, but it does mean log base 10 of x, so just a point of clarity. The second thing that I have to tell you is that you have to be really good with your properties of logarithmic functions before you can do this. So if you're not certain of those, you should probably go back and watch that video instead. So having all that assumed onto you, I'm going to show you what I would do here. Because the bases all match, I can follow these properties, and the first property says that if I see a multiplication sign between logs of the same base, I can multiply their arguments. So the argument here is this x, and the argument over here is this whole thing right here. So I'm going to do that. I'm going to combine this and say I really have log of x times x plus 1 is equal to log of 6. And because I just have one log on this side and one log on this side, nothing attached to the outside of them, and the bases match, I can drop the logarithms, right? It's just the equality properties of algebra. So I can just drop this and say, what I really have is this. I have x times x plus 1 is equal to 6. And then I have to start solving that algebraically. So if I expand this, I get x squared plus x equals 6. Hopefully you can see this is quadratic. And the way we solve quadratics is set them equal to 0. So I'll move the 6 over. We'll have x squared plus x minus 6 is equal to 0. Just doing our algebra 1 or algebra 2 here. Just doing our algebra 1 or algebra 2 here. We would get this. We would solve this out and say we have, what is it, x plus 3 times x minus 2 is equal to 0. Solve that, we'd get x is equal to negative 3, right? Or x equals 2. This is super important that I want to tell you right now. You have to go back and check these, because remember that the domain of logarithmic functions are values greater than 0. So you have to go back and make sure it doesn't screw up the argument. So I'm going to take that negative 3 up there. If I put negative 3 in here, this is not defined. It doesn't make any sense. So x can't be negative 3. The other possible value is 2. So if I put 2 in here, that makes sense. If I put 2 in here, 2 plus 1 is a positive number. Therefore, that makes sense. 3. All right? So you have to be really careful as you do this. If you want to check and see if this is true, we can do this again. We can just go to that rule of exponents that rule of logarithms that we know. We're allowed to multiply these two arguments. Same base. We get log of 2 times 3 equals log of 6, question mark? Well, yes, it does. All right? Look, I hope this is really helpful. It's really simple, but you have got to look at it carefully. And go back and make sure you have those properties of logarithms memorized. If you have any questions or comments, please let me know. And if you haven't already subscribed, please do. Thanks.